Hey guys, this is Professor Janacek, and I want to go over another example of solving a non-homogeneous linear differential equation using the method of undetermined coefficients. So here we want to simply find the particular solution, not the general solution, of y triple prime minus 4y prime is equal to t plus 3 cosine t plus e raised to the negative 2t. First off, take note that if we look at y triple prime minus 4y prime equal to 0, this is the associated homogeneous equation. And r cubed minus 4r equal to 0 is what we call the auxiliary or characteristic equation. Now this characteristic equation or auxiliary equation has the roots. Let's see, if we solve that, we get r is equal to negative 2, r is equal to 0, and r is equal to positive 2. These are all real roots, which tells us that the solution to this associated homogeneous equation, which I'll call y sub c, has the form, let's see, it's going to have a constant. I'll call it c1. That's from the root r equal to 0. And then the other two roots give us, let's see, c2, e to the 2t. Actually, let me write the negative. E to the negative 2t plus c3 e to the positive 2t. So this is referred to as the complementary solution. Solution to the associated homogeneous differential equation we refer to as the complementary solution, and this is going to allow me to make sure that I have the proper form for my particular solution. So now, taking a look at our non-homogeneous equation, the portion that makes it non-homogeneous, I'll call that g of t. You can call it really whatever you want, as long as it's not a y. Typically that is our solution, right? That's what we're looking for. In this case, our variable is y. That is t plus 3 cosine t plus e to the negative 2t. So looking at this, we can make our initial guess, which I'll call y sub p 0. Now we might have a few more variations on this guess, but we'll start with just this basic guess based off of g of t. So from the t portion, that gives me at plus b. The cosine portion gives me c cosine t plus d sine t. And the e raised to a power portion gives me e uppercase E times e raised to the negative 2t. Some things I notice here, I do see that the constant shows up in my complementary solution, can't have that, and this piece that has the term that has e raised to the negative 2t, that also shows up in my complementary solution. So those are not allowed. So in order to fix this, we'll make another guess. We'll call it y sub p1 of t. And all I'm going to do is multiply these terms by t. So I have at plus bt plus c cosine t. Let's get that. Plus d sine t plus uppercase E t e to the negative 2t. Again, all I did was multiply those two repeated terms by t. Now, I notice another problem here, that I now have the t term is repeated. Okay, so what do we do there? Same thing, multiply by t. I'll call this y sub p2. and just simply multiply one of them by a t as well. So I have a t squared plus b t plus c cosine t plus d sine t plus e t e to the negative 2t. Making sure you're using uppercase E there for the coefficient. All right, well, that actually looks pretty good. If I compare this with my complementary solution, I don't see any of the terms are repeated. They are all slight variations. All right, so this will be the form for y sub p, the particular solution. Let me just write that out again. And now all we have to do is figure out what A, B, C, D, and E are, what the values of those are. All right, so how do we do that? Well, I'm looking at a third order equation here, so let's go ahead and find up to the third derivative. The first derivative of this particular solution has the form 2at plus b, minus c sine t plus d cosine t plus, we have to use the product rule on this one. That's actually going to be negative 2et e to the negative 2t plus e to the negative 2t. Take your time with that. And of course, you could get that in a slightly different order. That's completely acceptable as long as you have all those terms. So that is, the first derivative. I'm not sure what I wrote over here. Y sub p prime. Now let's take a look at the second derivative. So that is 2a minus c cosine t minus d sine t. Need the product rule again for the second to last term. It's going to be plus 4et e to the negative 2t minus 2e e to the negative 2t, and then the last term is minus e times e to the negative 2t. All right, so looks like when I take the derivative of this last term, actually that's minus 2 e to the negative 2t, derivative of the last term there. But it looks like I can combine those last two terms. Let me go ahead. We are using something erasable, so let's go ahead and write that as minus 4e, uppercase e to the negative 2t. Well, that's the second derivative, and now we need the third derivative. So we get, let's see, that's going to be a positive c sine t minus d cosine t. Using that product rule yet again gives us what, negative 8 e t e to the negative 2t. Plus 4e. Am I doing this right? No. Plus 4e e to the negative 2t plus, for the last term, plus 8e e to the negative 2t. Again, I see we can combine those last two terms, so let me go ahead and erase that and rewrite that. That's going to be plus 12 uppercase E times e to the negative 2t. Just take your time with this. You are experts at taking derivatives, so just make sure you get all of these terms correctly and then combine before moving on to the next derivative. All right, well, now, since our differential equation is y triple prime minus 4y prime is equal to t plus 3 cosine t plus e to the negative 2t, we can write, let's see if I can get it all in here. That's going to be y triple prime, that's c sine t minus d cosine t minus 8et to the negative 2t plus 12e, oh dear, I can get that, e to the negative 2t, minus 4y prime. So 4 times y prime gives us minus 8at minus 4b plus 4c sine t minus 4d cosine t plus 8et e to the negative 2t minus 4e e to the negative 2t. And all of this is equal to, running out of room on this line on the screen, so I'll just write it below. That's equal to t plus 3 cosine t plus e to the negative 2t. Looks like we can combine some terms here, so let's go ahead and do that. Let's see, we have 5 sine t and minus 5d, oh sorry, hold on, that's 5c sine t minus 5d cosine t. Well, let's see, a couple of terms cancel. 12 minus 4, we have plus 8e e to the negative 2t minus 8at minus 4b is equal to t plus 3 cosine t plus e to the negative 2t. Now this is where we figure out what our coefficients are. We'll go ahead and do an association with these coefficients. I'm going to go ahead and do this in alphabetical order. Again, you could do this in any order. You will get a system of equations that you'll solve. You'll see these are going to be super simple to solve. So we have negative 8a is equal to 1. That's associating the t terms. Looking at my constants, we have negative 4b is equal to 0. Looking at the sine terms, we have 5c is also equal to 0. The cosine terms give us that negative 5d is equal to 3. And looking at the e terms, we have 8e is equal to 1. Solving each of these gives us that a is equal to negative 1/8, b is equal to 0, c is equal to 0, d is equal to negative 3/5, and e is equal to 1/8. There we go. We are ready to write our particular solution. So I'm going to go back to this version. Here it is. That's what my particular solution looks like. I just need to substitute a, b, c, d, and e. Therefore, y sub p of t is equal to negative 1/8 t squared. The t term is 0. The cosine term is 0. The sine term, we have minus 3/5 cosine t. The te to the negative 2 term, oh, that one, we do have something. What does that give us? That is 1/8 t e to the negative 2t. There we go. This is the particular solution. Remember to come up with the general solution. If you're asked to find a general solution, then you would put the particular solution together with the complementary solution. And if you have initial conditions, you could actually find C1, C2, C3 in this situation. But there you go. Enjoy.